All right, so defining our variables, A is your final amount of something. Usually in these cases it's money, but it's not always money. Okay, P technically stands for principal, which is like the amount of money you might invest, but it's also nice to think of it as initial amount or starting amount. Initial means starting, and principal is the money that you invest. R is the rate. And there's one thing you want to keep in mind when you're thinking of the rate. If I told you that you were getting 5% interest on something, what is 5% written as a number? 0.05. Very good. So just remember to use the decimal form, because if you use 5, what you're really doing is you're writing 500%. Okay? So use decimal. Okay. N is the number of times that your interest is calculated. So your interest could be calculated yearly. That would be 1 time per year. Your interest could be calculated monthly. That's 12 times per year. It could be calculated quarterly. That would be 4 times a year. So it's the number of times your interest is calculated. Per period. And usually the period is a year, but it's not always a year. So it might be the number of times per year, or your time period might be different. And then T is the number of time periods, which is often the number of years. So if I told you that your interest was calculated quarterly for 10 years, then N would be 4, because there's 4 quarters, and T would be 10, because there's 10 years. So it's going to be the number of time periods, which is often years. Good morning. All right, now, this 1 plus or minus r over n, it's not like the quadratic formula where there's 2 answers. There's just 1 answer. The plus would happen if it's growth. The minus would happen if it's what? Decay. Good. So it's not going to be both of them. Notice it's the base of your exponential. Do you guys remember what we called the base of your exponential last lesson? I was asking you to identify the what? It was like the growth factor or the decay factor. Remember that? And when I asked you to find the growth factor or the decay factor, it was the base of that exponential. So it's either your growth or decay factor. And actually, I'm going to write them right separately here. So 1 plus r over n would be a growth factor. Very good. 1 minus r over n would be a decay factor. Okay. So that's a lot of definitions, but we're going to use these formulas to solve some problems. You could have interest that's compounded a certain number of times in a year, or you could have interest that is compounded continuously. And that's a weird thing to imagine. Like, I actually can't picture continuously compounded interest in my head because it's compounded more often than every second. Okay, it's just continuously being compounded. And interestingly, you would think that that would make a lot more interest, right? Because you're compounding it so often. It actually doesn't. It makes a very small amount more interest when you compound continuously than when you compound quarterly or monthly or annually. Notice that there's this E in the formula. Has anybody ever seen that E in math before? No. Okay. It has a name. Its name is Euler's number. And you know how pi goes on forever? Euler's number also goes on forever. It's an irrational number. Just like pi or the square root of 2, it's irrational. So these digits, they go on forever. They don't repeat. If they went on forever and they repeated, it would not be irrational. But because they don't repeat, it's irrational. It is used as the base, the natural base. It's called the natural base because it actually shows up in nature. It's pretty good. Anyway, so you don't need to know all of this about E. You do need to know that it's approximately equal to this number if we have to calculate things. And we're going to be using this formula. A lot of people think of it as A equals PERT, but you have to remember that the RT is the exponent. Okay? All right, so let's go on to the problems and let's see if we can make sense of these. Reston, Virginia grows every year at a rate of 0.4%. Now, be careful with 0.4%. What would be the decimal equivalent of 0.4%?
It would be like 0.047.
Yeah, you guys are on the right track. So percent technically means per 100. So if you ever get tripped up and you're like, I'm not sure exactly what it is, you can divide by 100. So percent. The word cent means 100. So if you're not sure exactly where that decimal goes, you can do 0.47 divided by 100. Yeah, so 0.0047. But Josiah's going to verify for us. Did you get that? Oh, sorry. Anybody else divide it? 0.47 by 100? Okay, it should give us 0.0047. Okay, it's compounded annually. The population of Reston in 2019 was 58,404. What is the estimate for Reston's population in 2025? So, which of these are we going to be using? Are we going to be using the compound interest or the continuously compounded formula? Look at the wording. Even though your population doesn't technically jump up at the end of the year, right? Your population is growing all the time. It's calculated every year. See the annual rate? So that means we're going to use which formula, the first or the second? Okay, I know you guys want to say the second because that's the way we're actually growing in population. But because the rate that they give us is an annual rate, we have to use the first one. Okay? The second one would be if they could tell you how we're continuously compounding. They can't. So, because they just don't take that much data. They take data maybe once a year. Sometimes, like the census, they only take data every 10 years. So, for this one, we're going to be using the first one. So, A is the end amount. That's what we're trying to find out. P is the starting amount. Actually, you know what? We're going to start by writing the formula. Is it going to be a plus or a minus? It's a plus because our population's growing. Yeah, sorry. Okay, that's the formula. Plus because we're growing. Now, we don't know A. That's what we're trying to find out. What's P? We'll look back up. What did it say P is? The initial amount. So what's the initial amount? Yeah. 58,404. 1 plus, for our rate, we're going to use that decimal that we figured out. 0.0047. And then how many times is it calculated each year? Once, because it's an annual rate. Okay. Notice the same n is here and here. 1 times. And t is the number of time periods. So in this case, the number of years. So for how many years are we calculating? 6. Yeah. 6 years, right? From 2019 to 2025. So 1 times 6. All right, so some of this we can simplify without a calculator. For example, 0.0047 divided by 1 is 0.0047. And if I add 1 to that, it's just 1.0047, right? So we can simplify that here. And then we can turn to Desmos. 1 times 6 is 6. And then bring this down. Okay? All right, so once you have that written down, you can open Desmos or your favorite calculator and find an answer. All right. Do you guys want to try one on your own, or do you want me to work through it? I had 1 vote for me and 1 vote for you. Go ahead and try it on your own. I'll give you a moment to head start, and then after you have a head start, I'll start working through it. Yeah, it's the same issue. All right. I'm going to have you guys quiet down. I saw some really good working together, but I want to make sure that we all realize that when the car depreciates, it goes down in value, so you should have the minus here, okay? Check and make sure you've got the minus. 15% is 0.15. Make sure you've done that conversion. And then we're trying to find the end amount. If your principal is 1,500, 1 minus 0.15 over, what's n? 1, because it's compounded in 1 year. Asan, you have a question or answer? Go ahead. Say it again. I'm sorry. Oh, okay. Because it doesn't say compounded continuously. If it says compounded continuously, that's when you use the PERT. Okay?
So with the first one, is it compounded annually?
Yeah.
Does it have to be like compounded continuously for it to be the second one?
Yes.
Okay.
All right. So Carmen, you helped me simplify this formula a little bit. Can you tell me again?
Yeah.
So I'm going to keep the 1,500, right?
Yeah.
And then what do I get in here?
You put 1
Uh-huh.
minus 0.15.
What did that give you when you subtracted it? Did you subtract it yet?
Yeah, 0.85.
Good. All right, and then she also told me that the 1 times 1 is 1. Did you get a final answer yet?
No.
That's okay, because I know that right next to you, Gideon has an answer to share. Go ahead.
Yeah.
1,275.
Anybody else get that?
Yeah.
Good. Okay.
You put after.
So, like, what did we actually find?
Yeah.
Words-wise? Okay. How much money could you resell the car for after 1 year? So, this is going to be money, right? So, we'll put $. Resale price after 1 year. Okay, so only one thing changed for the 5 years, right? What letter changes? Is it the N or the T that changes in Part B? Sky? Yes, the T changes in Part B. So we're just going to change that to a 5. Everything else stays the same. Okay, I can't do that in my head. So when somebody has calculated it and compared with another person, raise your hand. Okay. Nice job with the hands, guys. Josiah, go ahead. 665.5. Who can confirm that answer? Raise your hand. Excellent. Okay. 665 point. Actually, what's after the 0.5? Because dollars and cents. Another 5? Is it like that? Okay. So remember, this is money. So for money, we can do dollars and cents, right? And that would be the resale after 5 years.
The number after the second 5 is 7. Will we round it to 5?
Oh, so it's 557?
It's 5, 5, 7, 9, 6. 8.
Okay. So that would round up to a 6, right? Yeah. Okay. All right, folks, quiet down. You are choosing between Bank Z and Bank K to invest your hard-earned $300, which you plan to use in 5 years. Bank Z offers 12% interest rate compounded quarterly. That means how many times?
4.12.
4 times. 4 times in a year. Bank K offers 10% interest rate compounded every minute. Now, I've never heard of that, but that's what happens. So, which would be the best choice to earn the most money after 5 years? And it does tell you that there are 525,600 minutes in a year. Isn't that in the song? Yeah. Okay. So before you solve, think about which would be better and hypothesize the best bank. Okay? Interest. So interest is money that the bank gives you for letting them keep your money in the bank. It's good. Yeah. No, so this is why it's good not to just keep your savings like underneath your mattress, because if it's underneath your mattress, it doesn't get bigger. But if it's in the bank, then you get more money. You already know the answer?
Yeah.
Okay. Let everybody catch up.
No, Bank K.
So why do you think?
You get 0.10.
Okay. So actually, this is a very valuable exercise. What do you guys think without even doing the math? What do you think is better? All right, so a lot of you guys are thinking Bank K because it's compounded more often, right?
Yeah.
But what's better about Bank C? Better, a higher interest rate, right?
Yeah.
So we are about to find out which is more important. So do the math, let's see. Which bank was better, guys? Bank Z. So what's more important, a higher interest rate or the number of times it's compounded? The higher interest rate is more important. Yeah. So $541.83 here. And then for this one, 300.
Yeah, I was just calling. Don't make it one.
So, if you are having trouble dealing with the size of those numbers, I just recommend that you put the entire formula in there at once. You should get about $494. 5, thank you. $494.62.
I still love to do it.
All right. So here's the interesting thing. Like, when people hear that you're going to compound your interest like 4 times in a year, they think that you're going to add 4 times as much money in interest. You're actually not. Like, the goal is to add about the same amount, and that's why the formula makes this adjustment. It's about the same amount. It is just a little tiny bit, usually more, I think, if you compound it more often, but not much at all. All right, did you guys notice these words down here? Compounded continuously. So that means even more often than every second. And so we need a new formula, right? So here we are. A equals P times E to the RT, which is Euler's number here. The E is Euler's number. Let's write the formula. All right, and then this time our principal is 1,500. E is going to stay E, just like pi stays pi, until you put it into the calculator. So you don't need to write down 2.7 because it's going to be rounded. If you use E, Desmos will give you a lot more digits than we're going to write. And then R times T 1 year. Okay? So let's type that into Desmos, see what it gives us. All right, let's do the last one here. So find the balance after 3 years. Sometimes for the exponent, it's kind of picky. If you put parentheses, it will let you multiply. Oops, that's not what I was trying to do. Try again. Times 3. You just type E. Just type the letter. All right, so after 3 years, I have $1,691.25. All right, annually means how many times in a year? 1. Semi-annually means n equals 2. 4, good. How many months in a year? 12. How many weeks in a year?
56.
Daily's a weird one. It's because of leap year, right? So Sky says either 365 or 366. Are there more years with 365 or more years with 366? 365. So if we were to average 3 years at 365 and 1 year at 366, what would we get? I think you're right. Let's try it out. You're thinking it's a quarter of each one? I think you're right. All right. So if this is the case, it is possible they want n equals 365, or it's possible they want n equals 365.25. You might need to see what Delta Math wants there. I think they want 365, but if you were on a test and you said n equals 365.25, I would be impressed. All right, probably Delta Math wants this one, but I like this one too.